Good
This
morning, everybody.
conference will now be recorded.
Good morning, everybody. So we have a rather like a news, rather sad one to share with you. I have Pompey from Intel, and Pompey will share it with us.
Hi, Ahmed. Thanks for the opportunity here. Can everyone hear me?
Yes, we can.
Right, okay. So, per Ahmed's point, very sad news from the Intel side. Our dear colleague, Dave Chalupsky, unfortunately, is no longer with us. He passed away a couple of weeks back. And unfortunately, he will not be attending these meetings anymore. I think a lot of the team on this forum knew him very well, especially with his long tenure in Ethernet and his focus on PTP. From the Intel side, we're obviously all very sad to see him go. While we do have representation from Intel, from this products group side, we'll see how we can align internally and support the work that he was doing, and bridge the gap that he leaves for us. So very sad news. Just wanted to let the team know that Dave Chalupsky unfortunately isn't going to be attending anymore.
Thank you, Pompey. Thank you very much.
Thanks.
Okay, so Elad, why don't you kick it off and we start with Michelle's basically.
Yeah, so obviously it's a day for everyone. Let's begin with our agenda. So last time we met, we provided an overview into the Open Grandmaster workstream led by Oleg and Datan, and I'm glad to say that the draft spec is now posted on the top webpage. So if you click on the webpage, you would see a link to the draft version 0.1, so the first initial draft, for everyone to comment and contribute. So we're looking for the continuous work on that work stream. And for today, we would like to focus on the second work stream, the second out of three that we have, which is PTP profiles. This work stream is led by Michelle from Facebook. And today, Michelle will provide us with some introduction to PTP profiles and an overview based on the spec. And we'll also lay here the groundwork for the contribution team, the core team of this work stream, and the next steps. Michelle, I'll hand it over to you.
Thank you. All right,
I'll make you the presenter.
Yeah.
And let you drive the screen.
All right. All right. Can you see my screen now?
Yes.
Okay, great. Yeah, thank you, everyone. So I thought today would be good to basically kick off the work stream on the data center PTP profile. If you remember in the first an original call we had, basically one of the scope, and there was a some kind of a charter put in place for this working group, as well as some scope and goals, which I've just copied here. You can see in this slide in section 1 here that said develop data center PTP profile and best practices that allow the deployment of time-sensitive applications over timing appliances and various interfaces. So this is a bit as part of this as part of this work stream, we want to basically tackle that item number 2 that you see here in the in the goal stack in this chart. Instead of doing an overview of PTP profiles, which I assume that quite a lot of people on the call are familiar with various PTP profiles that exist in various industries like telecom, automotive, power, industrial, enterprise, and so on. that we could, just basically jump into the meat of things and start really, presenting initial draft of what, this data center PTP profile would look like. I also want to make sure that this document or specification that we're going to be, on is not just necessarily going to be looking at developing a PTP profile, but various other aspects that touch network synchronization within a data center. This is a bit what I'm going to be walking through, a bit today, as a starting point. So what I'll do is just, skim through the document. I'm going to present, already, within that document, and then, open it up for, questions. Anytime, any of you have questions, we can definitely pause and, take the questions or, address any of them. So again, so the scope, I've touched on the scope right now. There's a, an introduction section for now. And then in section 3 now, there's a section that, is called PTP profile definition. And I want to read this out because this comes from the 1588 2019 standard that says a PTP profile is a document or a portion of a document specifying the set of PTP features and attribute values applicable to a PTP instance and written by an organization following the specification of 1588, 2019. So a couple of things in there. So obviously, PTP profile can be written by an organization. An organization can be the one, like a Open Compute project. There are certain requirements that we'll talk, a little bit later within the profile, maybe today, maybe not today, about when an organization wants to, write a PTP profile. The other aspect in this sentence also is that a PTP profile is a document or a portion of the document. And this is important because this specification is going to include a subset of this specification is going to include the PTP profile, but it will not, this document will not just contain, PTP profile. And you'll see later on, various aspects that we might want to also find that go beyond PTP profile itself. Let's go through, for instance, this section here where it says a PTP profile is a set of requirement options, prohibited options, and the ranges and defaults of configurable attributes. Essentially, when you design or develop a PTP profile, 1588 says that you should specify things like, and I'm highlighting them here, the best master clock algorithm options. And now in 1588 2019, for instance, they have made modifications to the BMCA algorithm by which you can now statically configure, the various port states in order to statically configure a best master clock, algorithm. So essentially, it does not need to be dynamic anymore. You also need to basically in a PTP profile define what are going to be the management options, that you relate to. You could say management is, for further study, out of scope, or you could say, well, within PTP, there's, the PMC, the PTP management client, which might be an option, that might be specified in this PTP profile for the purpose of managing, the different nodes. You need to define the path delay measurement option. So for instance, are you going to use, what we call the P delay or just the end-to-end delay request response mechanism? Other aspects that are very important is, if you open up the 1588 standard, you're going to see that there's a lot of what we call data sets. And each data set has a bunch of parameters with a lot of values in them. Most of these, data set the parameters and their associated values, are generally defined in a PTP profile. And what's more important is usually to define a default value for, each of these parameters. You also need to, define the various options that exist in 1588, and there's a large number of options for those of you that are familiar with 1588 that are required, permitted, or prohibited, within the profile itself. In 2019, they also came up with what they call uncertainty specifications. So this is something else that within a profile you have to advertise, how you're going to basically handle, uncertainty specifications, and we'll talk about that, later, and also touch on the transport mechanism. Transport here is basically, are you going to be using, Ethernet as the encapsulation mechanism, IPv4, IPv6, or come up with a new encapsulation, method, which is permitted, by the standard. So these are some of the options, that one needs to look into when you, define a profile. In section 4 is, additional topics, that go beyond PTP. So if you remember at the beginning, 1588 says that a PTP profile is a part of a document, which means that you can define additional things, beyond the PTP. And here is basically just a list of things that we discussed in the original call, but also the various others, in the past few calls that people have brought as, subjects that might need to be included, in the specification. For instance, it's important to, define an end-to-end network architecture and the various network elements, and I'll touch on this in the next section. Application requirements. What are we trying to do here, right? What are our, target metric and accuracy or precision levels that we're trying to, to meet? So, these kind of requirements can be defined, in this, document. The network limits, right? And, what is measurable or not measurable. We've talked about things like failure scenarios, holdover accuracies, the need, and if there is a need for synchronization. Other aspects include, and we'll talk about that a little bit later in the next follow-up sections. If you have a chain of transparent clocks, you might want to, or you need to somehow assign a, the PTP frames to a proper traffic class or DSCP code point or Ethernet BCP, in order to prioritize those messages as they traverse a set of network switches or routers. Other aspects are the operations and the management of, the synchronization tree or the chains of network elements and various data models. And this is where I think there's a lot of work, in my opinion, to be done. I think the industry has definitely not, I would say, or the different profiles and standards have really never really opened up or touched on anything that has to do with the management of, a synchronization network or, the operations, and so on. Lots of focus on precision, accuracy, protocol, anything, related to the management. There's a lot of work essentially that can be done there to better define that. And then we've talked about things like, the use of open source Linux PTP, PTP4L, and APIs to disseminate time within a timing appliance or across a set of timing appliance, right? So the problem is different if you're trying to do things, within a timing appliance. And I think 2 meetings ago, we've seen, from Oleg, on the open source Grandmaster, that, there's probably some level of specification that will need to go to be defined there within that work stream. But also here with, between the network elements also, it's important to define that. So section 5, for instance, is a reference model. I think it's important that we go through defining some initial, let's say, baseline, let's call them baseline network models that gives us a little bit of a guidance on how are we going to define, all of the things that I've mentioned above, right? Whether they are within or outside the PTP profile itself. So here, for instance, there's in this document right now, there's 2 models. Essentially, in model 1, we assume that it's a full chain of transparent blocks, and I'll show a figure in a minute. And in model 2, we're assuming that there's a chain of network transparent blocks with boundary clocks. So let me just show you quickly in model 1, which we call the full TC model, which is basically a chain of network elements. So you can basically decompose that model into 3 layers. At the top of the stack, or at the top of that model, is let's call it a time reference layer. This is where you have everything from your reference time source, your reference frequency source, as well as the root of the synchronization tree, which is typically in PTP, the grandmaster. That resides into that, into that layer. Then we have a second layer that we call, let's say, the network fabric layer, which is basically, nothing more than just a network that, switches or forwards or routes these PTP, messages between, the grandmaster and the bottom layer, which we call the server layer, which is a set of, in PTP terms, ordinary clocks. Now, that network fabric layer, there's various representations of what that, fabric looks like. Here, for instance, we're showing something that is, for instance, like highly symmetrical. It's a very short, so some of the attributes of that network fabric, it's highly symmetrical, it's very high speed, like 100 gig interfaces, or above, let's say nothing, below this, which is fairly new for PTP, right? Once you start scaling at these higher speed interfaces. The chain of transparent clocks here, like you can see, there's I don't know, in the picture, 5 of them. It's a very short chain. If you compare with things like in the power profile, you can have I think up to, I don't know if it's 120 type of transparent clocks, and in the telecom, for many years it was 20 network elements defining a chain. Here the chain is much shorter, but much more denser. And what does that mean, dense? For instance, in some of these fabric, the PTP frames that go from a GM to OC, from the top of that layer to the bottom of the layer, might not always traverse, the same link. Okay, and they might not also traverse the same set of network elements or links in both directions. That means you could have, for instance, the sync messages that go from, through one path, and you could have the delay requests that go through another path, right? So these are the kind of things, situations that we'll be addressing. Things like, for instance, other characteristics are, for instance, like the use of IPv6. Right? Very important in data center is to define the data center PTP profile with IPv6. And if you look in the industry, most of the profiles that have been deployed to date, none of them have really, really looked at IPv6. So one might say, yeah, but it's simple. It's IPv6. Sure, it might be, but it's important that it's properly looked at and make sure that if you adopt a PTP4L Linux PTP, that the IPv6 stack is properly let's say supported with all of the features that are going to be necessary per what the PTP profile is going to specify. For example, unicast, right? So here in a lot of these data centers, for instance, the use of multicast is just not present or not used. So in this model, for instance, all of the ordinary clocks have to communicate with one or multiple grandmasters using unicast. But we know that most of the profiles out there, they all use multicast, except for one or two of the profiles in the telecom where unicast is used. So similar in spirit here is what does it mean if we have to for instance use unicast? What are the different options like unicast negotiation, unicast discovery, all of these things down this document. Some of these things are specified or to be reviewed. Okay. The second model is, let me go to the figure. The second model is, for instance, in having a full chain of a transparent clock, essentially the node that is connected to the ordinary clocks, and view those ordinary clocks again, that server layer as just a very large number of servers, or in PTP terms, these would be the ordinary clocks. And here, for example, for scalability aspect, you might want to, considering putting a boundary clock here, right? So the OC communicates with the BC in unicast, and then the BC itself communicates with various grandmasters, right? Also using a unicast. So essentially, you're breaking that end-to-end unicast flow into two unicast, flows, or unicast. I think they call it unicast contracts in 1588. Then section 6 is just a bunch of additional, for instance, requirements or characteristics of based on these. Now that we've got at least two models to work with in terms of the time accuracy. I think we've talked in the past something, and we'll hear a little bit more about this when we start working the third work stream, which is the APIs and the accuracies of the applications, right? But something within a couple of microseconds. Other things here is that in this model, for instance, is that all of the nodes are PTP aware, which means that hardware timestamping is enable in each of these nodes and at each of the respective ports of each of these of these nodes. So that brings me to, for instance, section 7. And again, this is a walkthrough with the group here to just demonstrate a bit, or just to show a bit what is being specified. And yeah. So in section 7, this is where, for instance, when you start defining a PTP profile, generally 1588, by definition, mandates or requires that you define some of these fields, which you got to give the profile a name, profile number or version, a profile identifier. Which this profile identifier is interesting because it's it's basically a combination of what we call an OUI or a CID, which I'm not too sure if OCP has, but something we'll have a look at, which is this organizationally unique identifier, or this company identifier that you need to essentially have in order to identify that profile. The organization name that is developing the profile, and some kind of a source identification, which just the textual title of that profile. One thing here, I added a note here because in 1588-2019, and again here the 1588-2019 is new. It's got additional requirements in it, which means that and we all know that there's a lot of whether it's test and measurement equipment, whether it's software stack, whether it's like Linux PTP, a lot of it has been based on 1588-2008. Now in 2019, they additionally came up with things like profile isolation, which is something that OCP developing a profile will need to define. Essentially, what that means is, can you guarantee that, for instance, within a data center, you will only be the only profile running, within a data center, for instance, that there's no other profiles that will, be, for instance, going through the same, network elements or timing appliance, as this profile.
Practically,
So
no coexisting.
Yeah, exactly. So yeah, exactly. So if there is no coexistence of another profile, then you, the organization, can rely on what you call the domain number to differentiate the different profiles that an organization might want, to develop. Because who knows, right? Any organization can develop multiple profiles. Telecom is an example. Power is an example. They've developed multiple profiles, and you need to have a way to differentiate profile from profile, especially if those PTP frames, are on the wire, right? You need to differentiate the things. So they came up with something that is called also SDO-ID, which is a Standard Development Organization ID, which is an ID you can ask for IEEE. And this field, the SDO-ID now is a field that is on the wire, which allows you to differentiate, if you receive a PTP frame, okay, that frame belongs to a data center profile, or for instance, a telecom profile. I mean, who knows, right? We've talked about, edge applications. We've talked about, maybe like a grandmasters, the possibility of using the same grandmaster to, possibly use as a source for data center applications, but at the same time, it might be used for, to serve additional type of profiles. So anyways, the idea behind SDO-ID is there. Is to provide profile isolation, because there's been some problems in the recent years of various profiles conflicting or not specifying things properly. In section 7.2, for instance, here you see on the screen is the type of, for instance, clocks that are used, within the within this profile. I mean, there's nothing new here. This is just a one-to-one definition to what 1588 defines. I just want to point out also something that in 1588 there's this the use of the terms master and slave. We all know that we need to be better at using these terms, these terminologies. 1588, as I started discussing these things, I believe also in ITU. So I wanted to just, part this here also that, we might want to make sure, on how we use these kind of terms, within this document. The transport, for instance, like you've got to specify whether you're going to be using IPv4, IPv6, and so on. I'm going to skip some of the details here. Class as a service, what I said at the beginning. If you have a chain of transparent clock, you might want to consider, especially for the PTP event messages, to map them to, for instance, the highest priority, or the highest possible class of service within the network. This is basically just to minimize, latency between two endpoints, or minimize, the variation in latency between the two endpoints. I mean, the set of transit clock should be capable of, accumulating the, any kind of sources of delay within the, within the network element, and put this into, the correction field, which is essentially a cumulative value. But here, the guideline is, generally put this into the highest class possible. Okay, profile isolation, like I said, I was just discussing that a minute ago. Things like one step and a two-step clock, right, that you have to, for instance, define. And this is an interesting one here. Depending on the, the number of sessions or number of ordinary clocks, for instance, you have in a data center, the scale of the number of ordinary clocks might be, much larger than in anything else that has been, defined so far. Which means that two things. It means that if you can cut down the number of messages, which by the way doesn't take too much bandwidth, PTP doesn't, we all know, it doesn't take too much bandwidth, right? But there's an aspect of processing here that if you can, do a one step, the result of might be, a lot more higher number of unicast contracts that you can serve from a grandmaster. And second thing, for those of you that are familiar with PTP defines, some requirements, and I'll talk about this a little bit later, on how you schedule PTP frames, over the wire. And you got to meet these kind of requirements, which might impose some constraint on the number of unicast contracts, for instance, that a grandmaster or a boundary clock, could serve. In terms of message rate, essentially, there's just a table here that just says, maybe the minimum rate is 1 and the maximum rate, for instance, for an ounce is 8, and sync is 1 to 128. There's no specific requirement here, but this is an important also number, to consider for a couple of things, right? We all know that loop filters are somewhat dependent on the maximum rate of PTP frames that you receive. We saw that from the presentation 2 weeks ago, where some was mentioning 16 hertz, right, and how the show the low pass aspect and the high pass aspect, of and the result of additional noise that might be generated based on the maximum rate of PTP messages. So that's one thing. The second thing is, again, that scalability aspect, right? If you have a very large number of unicast contracts that you're trying to serve, there might be a lot of differences between using a lower minimum, a lower rate versus a higher rate. In terms of unicast, for instance, like I said, if you're going to use a unicast between a ordinary clocks and a master, or between boundary clocks and grandmasters, there's a set of things that need to be specified in the profile about unicast negotiation, discovery. There's a bunch of parameters. Now, this does not mean that you have to use unicast negotiation. You can still use unicast, but you don't necessarily have to use the negotiation protocol that is defined within 58. It's possible to define it, perhaps in a much simpler way. Yeah. So this is a bit, a quick walkthrough of what I wanted to present in terms of this item number 2 that we said we were going to engage, which to this definition of this work stream, which is the DC PTP profile. My question essentially to to the group is, now that we did just a quick walkthrough, is to see who has interest in working on the definition of this DC PTP profile specification.
Michel?
All right.
I would like to have a pause here and open up the stage for questions and feedback. Guys, thank you so much, Michel, for this overview and giving the floor back to you, team. I guess we have the whole house happy with the groundwork you put.
I assume there will be dedicated meetings for this workstream item created, and I'm sure we'll go into details at that point.
Absolutely. The intention here is that we publish the document in a way that everybody could access, and we would work on it as a work stream, dedicated meeting sessions, exchanges, and so on. Would you like to sign up for that, Alon?
I think I already have an email, but yes, I'm put me on the list.
Sure.
Yeah. Thank you, Alon. That's great to hear. Yeah.
Michel, I think you did a great job presenting that. I want to remind everyone that we also open up for new topics and new things that they think should be defined in order to solve the problem that we presented in our previous sessions. So that's also a feedback that we ask.
Yeah. So Elad, okay, let me see if there's additional comments from other colleagues. Okay, maybe not right now. These, for instance, this work stream, I think it can go, two ways, right? Definitely, we need to have perhaps separate meetings to focus on that topic, those specific work streams. In addition, I think a lot of the work can be done, or needs to be done in between meetings, right? Or else it's never going to end, right?
Yeah.
So that's something to also consider, right? Is in order to speed up, these things, these discussions, and so on. A lot of the things, need to be done, in between meetings, I think.
Absolutely. It should be a collaborative document that we can all add and comment. I think with a few iterations of the team, we'll get into the point we want to be. As a follow-up item, we will put this document into the right OCP format, convention formats, and we'll have it placed in a repository where all can access. So all of the ones who sign up can access. And Michel, we will announce further meetings for this work stream, right? We will provide the guidelines on where we're going to meet and discuss.
Michel, this is Archana. I have a quick question on this, on the scope. Just curious, is this, do we want to limit it to just the data center? Or do we also want to expand this to, say, edge or outside the brick and mortar data center, like maybe modular data centers? or something of that sort? I'm just asking.
Yeah, I mean, very, very good question. I think this, what we discussed originally was to, define a profile for the purpose of data center applications. Now, whether it's I don't know what's the difference between like mini data center or data center itself, but within the data center, because many other industries, like we discussed in the past, I've already defined their profile, like telecom, power, and so on. So I don't know if this answers your question, but yes, if the data center, whether it's a centralized or distributed or type of infrastructure, and that it's within the realm of data center applications, I would say, yeah, we should put that in scope.
Okay. Yeah, because I think some of the other profiles that are coming up are very like within the rack specific, if you will, network switches or racks or storage, things like that. And they don't really describe the environment that these nodes may be going into, like a networking node or a storage node or a rack, or even power. They kind of leave that vague. And that's why I was asking that question. I think it's kind of implied, but not quite specified.
Archana, my 2 cents, Archana, if I may, with contrast to the other work stream, I think that in this work stream we are kind of filling the gap where we saw that there is a missing profile for data centers. At the edge, there are existing profiles which we think that they degrade, they are starting to be deployed, and so on. And actually, most of the things that Michelle talked about are very unique to data centers, like the fact that there are data center with or without multicast, or with and with or without traffic classes, and fatter source clock trees, which is much different than the edge. So those are the things that are unique for data centers. Those are the things that require us to define a new profile.
Perfect. Okay.
Yeah, precisely. Yeah.
Yeah, but to go in a slightly different direction from that, I think the question isn't whether we need a new profile. At least for me, the question is, I'll call it interoperability with other profiles. Imagine a data center that's providing services that require interacting with devices outside the data center and doing either supporting an additional time domain or translating time domain when something enters the data center.
Yeah.
I'm not saying we have to answer it right now, but I'm saying we at least want to consider those types of applications.
No, that's fair. Okay. All right. Thank you. I appreciate it.
Yeah, Michelle, I have 2 questions. So the first question is, are we assuming a specific architecture for the data center like spine and leaf, or we are going to work with any architecture?
That's a good question. Right now, it's similar to a spine and leaf, for instance. But I think we have to be careful on the on the network, trying to define a network architecture, right? I think within the profile, generally you define like the encapsulation or the transport, right? You define maybe the length of the the length of the chain itself, right? Which a chain is just a number of network elements that are arranged in a specific architecture. So yeah.
At this point, I can also wear back my Mellanox hat again.
NVIDIA,
NVIDIA hat now. We, of course, this is our bread and butter, those markets. And we definitely see that, for example, in storage, the popular topology is FAT-tree among many flavors. And in high performance computing, you have very unique topologies, even with exotic names like Dragonfly. But in data centers, it's spines and leaves. as far as we know. And we will make sure that it works with spines and leaf. If you have any specific other requirement, this is the place to come front and say we'll be happy to discuss.
But we have to decide. There are so many architectures for the data center. Spinal leaf is one of them, but it is most popular. It's factory. There are many others. Are we going to start with the spinal leaf, and if there is a need for others, we take care of it, or we are going to explore all viable architectures?
Well, what specifically bother you other than spinal leaf? What are you familiar with data center architecture?
Factory. Some people are using ring, optical ring.
Using what? Sorry.
Optical ring is you can put all the switches and servers on an optical ring. Some people use factory. Some, but majority use spinal leaf. So if we just focus on the spinal leaf, we may get the job done quicker. But if we also examine all other architecture that might be used for different applications for deployment, then the job will take longer.
Yeah.
I think what we should do. Sorry, Michelle, go ahead. Sorry.
Yeah, no, go ahead, Dutton.
I said let's articulate the things that are tightly attached to the topology in the profile. You mentioned a few while you pass it through. We might miss some, but let's articulate it and see whether we can include more topologies or what is the other.
Yeah, I think it's important to look at it also from synchronization aspect, not to look at the problem from a network problem. We're trying to disseminate time, and I understand, there's a lot of details here. That's why we need, those reference models are somewhat important, because out of these reference models are going to come out various properties or characteristics from a synchronization point of view, right? Like things like what we discussed, IPv6, for instance, versus Ethernet, right? Things like, using 802.3x, right? So for instance, like pause frames, which we know in some data centers are used, let's say by NIC cards, which can sometimes, be problematic for PTP, right? Mm-hmm. So whether you have a ring or whether you have a tree-based type of topology, you still have the problem of what do you do with pause frames, as an example.
That is a very good point, Michelle. I was just going to ask you about this. Exactly, pause frames, probably not only pause frames, QCM also. All these data center bridge stuff, which is developed on IEEE 802.1, will have an impact on PTV. There is a new project now that we are working on, which is congestion isolation, and that if it doesn't differentiate between BTB 1588 messages and other messages, might even discard them. So you are right. This is a very good point. I'm glad you raised it. We have to be cautious regarding what we do regarding all these quality of service that standards that are developed or being developed in IEEE for data center bridges.
Yeah. So
Good point.
Michelle, we have data center switches which support SYNC as well, right? Where we can configure SYNC to derive the frequency. So why it is not discussed in this profile? So you assume that all the devices which are placed in the data center doesn't support SYNC.
Yeah. So I think at one point I mentioned here synchronization, right? So whether you want to use a SYNC, whether you want to use, for instance, the rate, right, which is another way to calculate frequency corrections using PTP, right, and not SYNC. There's various ways to do synchronization, or whether there might be cases where you, for instance, don't necessarily need to carry, frequency, right? So these are the kind of things that go beyond the profile, because the PTP profile does not necessarily mandate, or it basically is silent when it comes to frequency itself, right? And the method by which you want to distribute frequency. But yeah, very very good question. Yeah.
And then also 1588 2019 defines security, where you exchange PTP messages over with using authentication TLVs, or which is integrated mechanism, or we have a IPsec or MACsec. So what is the scope of that in this profile? So you're not considering security at all for the PTP messages?
Yeah, no, actually, I think it is somewhere in the document. So security, there's an aspect, from PTP, like you said, it's an aspect from the network, and also we, at one point, I think about what we call GNSS vulnerabilities, right? Which is another form of security, right? Because, for instance, like we've talked.
So GNSS vulnerability, when you talk, it comes from the problem of having a GPS interruption. When I say, the PTP message itself is not secured.
Yeah.
So
yeah, I get that. Yeah.
So I'm talking about that part. So are you considering, exchanging PTP where you have each packet is getting authenticated in the data center, at least PTP packets, because the standard defines a way of doing it.
Yeah, I mean, it's something that can be, considered. We can look at in 2019 exactly how, they find that. I've seen some of the work and how this fits into, the definition of a profile. Yeah.
And then also, see, you mentioned about having a 2.5 microsecond accuracy with respect to GM, and then 5 microsecond accuracy with respect to in between the ordinary clocks, right?
Yeah.
So now, so at least if you look at the telecom profiles, they define a way of traffic profiles, what kind of impairments that the network consists of, and then the frequency should be of this much with the traffic and without traffic, without impairments, I would say. So because the number 2.5 microsecond is a number, but what kind of traffic profile, at what traffic impairment we need this, are we not defining this specification?
Yeah, a very good question. So that number is like a hypothetical number right now. I think that there's going to be additional talks, later on, hopefully, that especially when we talk about the need for the applications, because it's all driven by the application, what the applications, need. The second point is in this profile, we assume that every node is going to be PTP aware. And that means now we have to better understand what does traffic impairment mean, and all of these nodes are PTP aware, which is very different than in a network where the nodes are PTP unaware. Right? The types of impairments and the level of is very, very different, in both models. And here we assume that not assume all of the network elements are PTP aware through either a transparent clock or a boundary clock.
Okay. Yeah, even the boundary clock or the transparent clock, they have a certain performance metrics has to be defined. So what is each node? Yeah, okay, I got you.
Yeah. And I think this is a bit what we mentioned here, the time error budget, and perhaps it fits into what you're referring to. Is that on a per node basis? you know, there
Yeah,
might be a specification or a number assigned on a per node basis.
okay, yeah.
So, Michelle, I think at the beginning of this tab conference calls, Ahmed mentioned that the team is open for new ideas. So, BTP, for example, yeah, it is used in many applications and has many profiles, but it is packet based and suffer from all packet based switching issues, like this priority pass frames, for example. So I mentioned at that time that there is some people in Davis University invented this DTP, data center time synchronization protocol, which overcomes some of these limitations. Will you consider also looking at something like this, or you will defer that maybe to later stage and will focus initially only on PTP? What is your?
I think for this specific document here, as part of this first work stream, it's a data center PTP profile, right?
Okay.
That assumes
I would
that
say limit to the data center and then edge in the sense of edge data centers, the ones that's sitting at the edge or the fog of the network.
Yeah, but I think what Michelle is saying, it is yes, data center, but we'll focus only on PTP for these documents. Perhaps maybe later we can discuss other technologies or protocols like DTP.
as a start, yes, correct. And using PTP because PTP, there's quite a lot of I mean, we've already discussed a bit. There's a lot of test and measurement equipment tools that exist. There's a lot of stacks that exist. There's open source stacks that exist. There's a lot of silicon that embeds PTP logic or functions into them, right? So that's some of the reasons why this first profile uses PTP. But nothing says that you cannot develop additional things, right? In for instance, separate specifications.
Okay.
And in the future, we might need to maintain these separate specifications.
One thing I'd like to add, Hasham, thank you for always bringing things like new things in this meeting and make it like I was looking at it right now. It's pretty interesting, and we are absolutely open to anything new. Like we're not basically locked on one thing. Like right now we see PTP is helping. We're going with it further. If something else comes in, we go further. The good thing about PTP is like most of our hardware is already like compatible with it, and we don't need additional cabling or something. But I mean, like we're always open to anything. Like ultimately, we just want to bring time and synchronization. Whatever delivers it, great. So we're open to that. So it will be also good if you. I think we brought it up like a while ago. Like it would be good if you can put this in form of a presentation and present it, let's say, in this forum. In some weeks, let's say, then what's the latest, what's in the market, or alternative to PTP, or
absolutely, that would be a good idea.
Great.
That sounds really good. We are at the top of the hour, at the end of the hour. So thank you, Michelle, and everyone here for all the great feedback. This is probably the first workstream meeting we had for PTP profiles. Archana, I will ask you to support us with the proper document formats, and expect for you here on the call and on the email group, expect the announcements of where we're going to place it in the next work meeting.
Yeah, Elad, let's you and I and maybe Kelvin take this offline and figure out what's the best way to do this in terms of work streams, and even the PTP profile, the way that you've structured it in terms of what you need from us there. I'll make sure that Rajiv is also on the call, and we can get all the details that you need. And then what we'll do is update the wiki with that information so that anyone that comes in can find that and get a link to those workstream calls on the wiki. Does that sound like a plan?
Awesome.
Yes.
Let's take it offline.
Yeah.
Okay.
Thanks, Michelle. This is a great presentation, and looking forward to work with you. Take care. Bye.
Thanks, Hisham. Yeah. Thank you,
Shukran,
everyone.
Hisham. Thank
Thanks
you.
for all the questions. Yeah.
Yeah. Thank you, Michelle.
Okay, bye.
Have a good day.
Very good.